In this video, I'm going to talk about exponential equation. So get ready with your pencil and a piece of paper for more examples. All right. Now, when we say exponential, okay, exponent, remember we've already done with the fundamentals in indices. Okay. So we should be able to explain what is meant by exponent, index, or power. Now, exponential equation has to do with equation in which the power is a variable. When we say variable, we mean the letters, okay, A up to Z. So we can form, okay, or we can write from the alphabet. So we can say 3 exponent A equals to 8. Okay, so this one is a typical example of exponential equation. Why? Because we have the power here as a variable. Okay, that's what we are going to do. Now, to start with, let's observe the following. 2 exponent x equals to 4. So this one is a typical example of exponential equation. But how do we solve for the given variable? Now, 2 to the power of x equals to 2 to the power of 3. Before we can solve for x, we have to make sure the bases on both sides are the same. So always make sure you check that. So we have 2 here, 2 there. Therefore, I can conclude that x equals 3. So since the bases are the same, we say x equals 3. So we have x equals 3 here. Now, we can cite so many examples. 3 to the power of x equals to 3 to the power of 4. We have 3 here, 3 here. So x is simply 4. But at times, you won't get the basis being equal straightforward. You have to, adjust it and make it equal. So situation like this side is 2, this side is 4. Don't say x equals to nothing here. Okay? 2 here, 4 here, and 4 is the same as 2 times 2, that is 2 squared. Okay? So since 4 is the same as 2 squared, in place of 4, I'll put 2 squared there. And therefore, I'll get 2 to the power of x equals to 2 squared. Therefore, x equals to 2. As simple as that. Now, let's observe the following. So you can pause the video and give them a try. So let's look at this. 3 to the power of x equals to 27. Now, at times, we get, okay, the multiples of the smaller number on the other side. For instance, 3 times 3 times 3. So 339 times 3, 27. So 27 is the same as 3 to the power of 3. So this side, 2 times 2, 4. 2 squared is 4. So that's the meaning. So you will say 3 to the power of x equals to 3 to the power of 3. X equals to 3. Not a few. Now, before we solve proper examples, let's observe the following. Okay, so 8 is the same as 2 to the power of 3. You can note them down. So note them down. So 8 is the same as 2 to the power of 3. 16 is the same as 2 to the power of 4. 27 is the same as 3 to the power of 3. And 64, it can be, so if we are to use 2, we can say 2 to the power of 6. Okay. Now, 64, this 64, let's check. Now, 3 to the power of 4. What is 3 to the power of 4? Okay, so let's make it 4 to the power of 3. Yeah, so on the calculator, this side is the same as 4 to the power of 3 and the same as 2 to the power of 6. Now 1 to 8, 2, 5, 6. Okay, and take 2. So you can try them. So 1 to 8. Let's look at 1 to 8. 1 to 8. 2 here. 2 here, 6. 2 here, 4. 64. 2 here, 3. 2 here, 2. 2 here, 1. Okay, 2, 1, 2. So 16. 2, 8, 16. 2, 4, 8. 2 times 2. So 1, 2, 3, 4, 5, 6, 7. It means 1 to 8 is the same as 2 to the power of 7. Now let's look at 256. 256. So 2 here, 2 here, 1. Okay. And then 2 here, 2. And the 1, 2, 8, 16. So we have 1, 2, 8. Okay, so since 1 to 8 is 2 to the power of 7, this one will just add one more. So 2 to the power of 8 will give us this, because this side is 2 to the power of 7 plus another 2. So 1, 2 to the power of 7, that will be 2 to the power of 8. So knowing the following, let's solve the examples below. All right, so let's observe the following examples. So the first one has to do with 3 to the power of x equals 9. So this side is 3, and we can change this one to 3 squared. So we have 3 to the power of x equals to 3 squared. So when x is simply 2. So we have x equals 2. Okay. Now let's observe this. 64 and then 16. Now 64 can be 4 to the power of 3, and 16 can also be 4 squared. Or if you want to use 2, you can do that. Okay, so 64 equals 16. Now if you want to use 2, 64 will be 2 here, 32, and 32 is 2 to the power of 5, so that will be 2 to the power of 6. If you want to use 2, this side will be 2 to the power of 6, and we have x there ready to multiply, and this side will be 2 times 8, 2, 4, 2, 2, so 2 to the power of 4. Okay, so we have this information. We have 2 here, 2 there. So 6x equals to 4. Therefore, x equals to 4 on 6. 2 here, 2, 2 here, 3. which is the same as 2 and 3. And if you don't want to use 2 and you want to use 4, okay, if you want to use 4, so that will be 4 to the power of 3 against 4 squared. So we have this equals that 3x equals 2, dividing both sides by 3. The side will cancel. X equals 2 on 3. We have this. So this one is the same as this. As simple as that. Okay. Now let's look at the next example. So we have this. 3 to the power of x plus 1 equals to 27. 3 to the power of x plus 1 equals to 27. Okay, so let's be very careful here. So we have this, okay, equals to 27. So let's change this 27. So that will be 3 to the power of x plus 1. So 27 will be this number multiplying itself 3 times. So the bases are the same. You can equate the powers. X plus 1 equals to 3. Therefore, x equals to 3 minus 1. And x equals to 2. As simple as that. Let's look at the fourth example. Now, the fourth example, this side is 2, and we have no option but to change the left hand side. So we have 8 2 to the power of x minus 8. Okay, so let's look at how this one, how it's going to be. Okay, so we have this, we have this, but don't forget that the bases are not the same, so we can't equate them. So let's change this one. So that will be 2 to the power of 3. To the power of 3 is 8. But if remember, if you do this, it's wrong. Okay, because if this side were to be, let's say 8 to the power of t, we have said 2 to the power of 3 times t. So the same thing, we multiply this, and this side will be x minus 8. So over that, we have this and that. So x equals to this. So 3x minus 6, x minus 8. So let's group like terms, x here, and we have 6 here. So we have 2x equals to minus 2. So dividing both sides by 2, x equals to minus 1. Okay, x equals to minus 1. So let's look at the fifth one. Okay, so we have 3 to the power of x minus 2 equals 1 on 81. Take your calculator and let's observe this. So start multiplying 3 by itself. So once you get to 81, you count the number of times that give you this 81. So if indeed 3 times 3 times 3, so 3 3 9, 9 3 27 times 3, that will be 81. So this one is 4, 1 2 3 4. So that will be 3 to the power of x minus 2 equals 1 over 3 to the power of 4. But let's be very careful here. Something is fishy here. The right hand side, okay, is supposed to be in linear form so that we can equate the powers. So let's record this property. 1 on a to the power of n is the same as a to the power of minus n. Don't forget that. So with this, I can say t to the power of x minus 2 equals to 3 to the power of minus 4. All right. So have this that. So x minus 2 equals to minus 4. Therefore, x equals 2 minus 4, then x is minus 2. As simple as that. All right. Now let's look at the last example. So we have this 2 to the power of. Okay, so let's make this one simple here. So we have 2 to the power of 3x minus 1. So remember this one is product. So we can say 1 to 8, since this side is 2, 1 to 8 will be 2 to the power of 7, okay? Times, now square root of 2 will be 2 to the power of half. Now let's perform loss of indices. Remember, when the bases are the same and we are multiplying, we add the powers. So 7 plus half, okay? LCM is 2. 1 to 2, 14. 1. So 15 on 2. So we have 2 to the power of 3x minus 1. 2 raised 15 on 2. So we can equate the powers. Okay, so let's equate the powers. So I have 3x minus 1 equals 15 on 2. So we can make this side over 1 and do cross multiplication. 2 out, 3x minus 1 equals to 15. So that will be 6x minus 2 equals 15. 6x equals to, so this side in will be 17. So over 6, over 6. This side will be 1x is simply 17 over 6. Alright, subscribe to this channel for more exciting videos like this. Alright, so see you in the next video, whereby we throw more light on some of the complex questions. Okay, alright.